The ground beneath our feet groans, a deep guttural rumble. It begins as a whisper, a subtle vibration. Then, the fury is unleashed. Modern cities, monuments to our own perceived mastery, tremble like leaves. Glass rains down like shattered ice. Steel, the very backbone of our world, contorts and twists. We believe we are advanced. We think we understand the forces of nature. Yet when the earth truly speaks, we are humbled. We are reminded of our fragility. Could it be that we are not the first to witness such devastation? Consider the ancient world. Imagine cities of stone and sun-baked brick. Greece, Mesopotamia, the Indus Valley. These were not lands immune to the earth's temper. They existed on fault lines, literal and metaphorical. Their chronicles, their myths, are filled with tales of earth-shattering events. Were these mere allegories? Or were they fragmented memories of terrifying realities? The ancients lived closer to the earth. They observed the patterns of the stars, the migrations of animals, the whispers of the wind. History whispers of curious figures, men of genius whose works hint at forgotten capabilities. Philo of Byzantium, an engineer and writer from the Hellenistic age. He lived in a world of burgeoning science, of Alexandria's great library. He wrote of mechanics, of war machines, of wonders. Among his accounts, or perhaps accounts attributed to him, are unsettling descriptions. Tales of sound, not just any sound, but sound used as a weapon. Sound capable of causing destruction. Could this be a fragment of a larger lost understanding of vibrational physics? Philo, it is said, described devices, instruments that could project focused sonic energy. The purpose? To shatter stone, to bring down fortifications. Imagine the scene. No siege engines battering gates, no flaming projectiles, just a hum, a vibration, perhaps imperceptible at first, then a resonance, growing in intensity, until the very stones of a city wall begin to shake. They grind against each other, and then collapse. Centuries later, another mind grappled with the unseen forces of the universe, Nikola Tesla, a name synonymous with visionary science, with electricity, with resonance. Tesla was obsessed with vibration. He understood, perhaps more intuitively than any of his contemporaries, that everything has a resonant frequency, a natural rate of vibration. He famously claimed that with the right application of resonance, he could split the earth in two. His experiments were legendary, and often alarming. Tesla's work with mechanical oscillators is particularly pertinent. He developed small devices that, when tuned to the precise resonant frequency of an object, could induce powerful vibrations. One famous story tells of him attaching such a device to a steel beam in his New York laboratory. Soon, the building began to shake. Machinery vibrated. The ground itself seemed to tremble. Tesla had to smash the device with a sledgehammer to stop the escalating chaos. Silent sentinels, relics of a forgotten seismic science. Archaeology unearths more than just pottery and bones. Sometimes it uncovers objects that defy easy explanation. Objects that hint at a sophisticated understanding of natural forces. Consider the so-called vibration traps found in some Roman ruins. These curious underground structures remain debated. Some suggest they were for water management, others propose a more intriguing function. Could they have been designed to dampen seismic waves, to protect buildings from earthquakes? Then there is Zhang Heng's seismoscope from Han Dynasty China. This ornate bronze vessel could detect earthquakes miles away. It could even indicate the direction of the tremor. The precise mechanism is still debated. It shows that the ancients were keen observers and inventors. They sought to understand and anticipate earthquakes. These are not isolated examples. Around the world, we find curious acoustic properties in ancient sites, chambers that resonate at specific frequencies. Lost to the abyss, cataclysm, design, or cosmic warning? Myths and legends across the globe tell of cities lost, cities swallowed by the earth, cities drowned beneath the waves. Atlantis is the most famous, of course, but there are countless others. Like in ancient Greece, submerged by an earthquake and tsunami. Dwarka, off the coast of India, its submerged ruins hinting at a once great port. Port Royal in Jamaica, the wickedest city on Earth, vanishing into the sea after a catastrophic quake. These are not just stories, they are echoes of real events, real cataclysms that wiped civilizations from the map. But is there more to these tales than simple destruction? Could the very design of some of these lost cities have played a role in their demise? We often assume ancient peoples built haphazardly or simply where resources were plentiful. But what if some settlements, particularly those in known earthquake zones, incorporated principles of seismic resistance? And what if, in some cases, this knowledge was flawed, or the forces unleashed were simply too great? The oscillator's secret? Did Tesla rediscover ancient power? Nikola Tesla's earthquake machine was no mere flight of fancy, it was a real device born from his understanding of resonance. He called it a telegeodynamic oscillator. Its purpose was to transmit mechanical energy through the Earth. He envisioned it for communication and detecting mineral deposits, but its potential for creating vibrations was undeniable. He spoke of reducing a building to rubble with a tuned oscillator. Did Tesla stumble upon something new? Or was he tapping into ancient knowledge? Consider the megalithic sites, the massive stones moved with precision. Could controlled seismic energy have been used? Imagine a technology that could reduce the weight of a stone block. Such concepts sound like science fiction, but Tesla's experiments showed focused vibration could achieve remarkable feats. Legends speak of sonic levitation and tools shaping stone like clay. Monuments or mechanisms, the enduring enigma of ancient structures. We stand before the great monuments of antiquity, the pyramids of Giza, Stonehenge, Sacsayhuaman, Teotihuacan. We marvel at their scale, their precision, their endurance. Mainstream archaeology tells us they are tombs, temples, observatories, and undoubtedly they served these functions. But is that all they were? Could these enigmatic structures, often aligned with celestial events and built with seemingly impossible engineering, have had a deeper, more dynamic purpose? Consider their construction in seismically active regions. Many ancient sites sit near fault lines. Was this a reckless choice or a deliberate one? Could these structures have been designed not merely to withstand earthquakes, but to interact with them? Perhaps to dampen seismic waves, as some theories suggest, for the unique foundations of certain Japanese pagodas? Or more radically, could they have been part of a global network? A system designed to monitor or even to influence telluric energies and tectonic stresses? Devices rather than just buildings? The sheer mass of these structures, the specific types of stone used, their often intricate internal layouts with chambers and passages, all these elements invite speculation. What if the geometries, the alignments, the materials, were all part of a lost technology?